Thank you, everybody, and welcome to my talk. So my talk is called Inside Data-Driven Schemas with Malli, and my name is Tommi, as introduced. I'm from Tampere, and I co-founded this company called Metosin. And about clojureD, I was supposed to have this beautiful slide, and 30 minutes ago we didn't have any kind of announcement, but because we have internet, 15 minutes ago we had that. So clojureD, call for speakers should open in 1 week. And we are going back to Tampere, so welcome. Hope I'll see you, everybody there. But this talk, first about expectations. I've always explained that Clojure is a data-driven language, but Eric Norman had this clear separation. There are actually two styles. There's the data-oriented, which means that we program with data, we model the entities data. And then there's the data-driven, which means that we build these DSLs with data and interpret or compile them. And I will show that actually we can combine the two and build something beautiful out of that. But let's start with a restaurant, my favorite lunch place in Tampere. So how would that look like in Clojure? Well, it's just data, so maybe something like this. So it's a map, it has name, tags, stars, address, a submap, and we have a comment that it's like a restaurant. So that's kind of nice, but the computer doesn't know much about that. We can make it better. We can lift the type as a field in the map, and now even the computer knows that if it gets a map with this type, it's a restaurant. That's nice. And if we are building this multi-tenant system with their multiple representations of a restaurant, we can have these globally unique type names, and now it's specific customers' view of a restaurant. With spec, it would probably the modern Clojure, and the restaurant looks like this. So all the attributes are fully namespaced. This is awesome because now you have just one attribute and you know exactly what is that. So if you have my domain restaurant name, it's always the restaurant name. And that's for computers, programs, that's awesome. For humans, that's quite verbose. And another thing that it limits our capabilities of building these truly dynamic things because we have to globally register them. So we are not going to use that in the examples. So back to the simple version. So this was a restaurant, and we should write some programs with that. And it's just data, so we need some kind of tools for doing something useful with that. So in other languages, we'll probably make these domain functions to work with that, but in Clojure we don't have to. We can just use the core functions and do whatever we want. And this is really awesome. This is the data-oriented side of Clojure. And where do we need types? Because we have everything. We just model the restaurant and write a program with that. So we don't need types, right? Actually, no. Yes, we need something. And there are options. In Clojure, there are always options. So we have typed Clojure, it's back on track, it's being developed, that's awesome. We have the prismatic schema, that's really old, from 2013, it's also great for runtime stuff. We have clojureSpec, it's a future of Clojure, it's also awesome. And we have these non-Clojure things, and Malcolm is going to talk about the JSON Schema, so I'm not going to talk anything about that. But so many tools, so would it be nice to have this one tool for everything? So we are using several tools. So we have clojureSpec. It's the future of Clojure. So let's put everything in. Let's take the runtime transformations from schema and all the internal stuff we have ever developed, put it there. Maybe something from the external things, and then just generate those external schema formats what we need for API documentation. And this would be great. And we tried to do that. This library called spec tools, the missing stuff from clojureSpec, and that was really awesome. It's a horrible hack, because there's stuff that it's not meant to be done in clojureSpec, but we didn't know that. We just try to make it work, and it's this external lump of things that it doesn't go there, and it's okay, because by design, clojureSpec tries to do something. It's really good at that, but putting everything in there might not work. And it's a question of expectations. So what are the expectations? So we wrote ours like this. So we are building these really dynamic systems, multi-tenant systems, and the data models are data themselves. So the customers want to modify their schemas at runtime. We want to persist them We want to transform between formats, and this is like the dynamic world. And we have been building many applications for customers like this, and like this is the vision. Some wise words about the expectations, so I will read this. So if you have expectations of others that aren't being met, those expectations are your own responsibility. You are responsible for your own needs. If you want things, make them. Who wrote this? Rich Hickey. Rich Hickey wrote that in his open source is not about you rant. Gist. So what do? We want something, so let's just build our own schema library. What could go wrong? So it's a Lisp, you can do these things. So the idea is that like, what if schemas were only data? Like, we already have Hiccup and Regent and our internal tools and Rated, which are all like data-driven, and they work really well, so the idea works. And we could take the best parts of schema and spec and JSON schema and whatever and try to like fuse something out of that. We should be able to program with the schemas and like make something really like fun for developers to use. And this small library, which is extendable in any way, so if someone wants something on top of that, it should be doable. So we started like prototyping, so is it doable? And what came out is Malli, and Finnish is like a nice language because you write things as you pronounce them. So it is Malli, you pronounce it Malli, and that's about it. And there's these hexes and spells below that, which is the official like pronunciation guide, but for non-Finnish. But it means a model. And the basic idea is that this really simple syntax, you have either type or these like vector of type and optional properties and some children, like the Hiccup format. So this would be a vector of some properties and about integers. And the same could be represented as a map, and Malli supports both. This is behind the scenes, the later one. But really simple. And some example schemas, int, it's a predicate, but it translates into this integer schema. Something equals 43, it's like constant, a tuple, and a map. And to get something useful out of this, you have to have some applications. First application, validation. You validate a schema or a Schema AST and give a value, and it says like true or false. This is really simple. Oh, there's the maybe. I guess you have seen the maybe not talk by Rich Hickey. That's a really good talk. And Rich highlights the like context-specific need for like these nillables and optional keys. And we thought about this, but for Malli, we wanted to model all the possible optional keys and maybes, because in real life, we have those. When you like work with the external words, they have nulls. They have optional keys, so we just want to support everything, so being pragmatic over idealistic here. So we have maybes. A more complex schema, this is like AND, which has a map and a function. And the maps are open by default as in JSON Schema and in spec, but you can close them with this property called closed. It has x and y, positive integers, and this function which says that x must be greater than y and some extra hints. And you can validate that. That's nice. But the schema should be data, and this function is just a function. So when you evaluate that, you have lost the source code, and that's gone. But no problems. We have libraries for that. So SCI by Michel, hopefully pronounced that right, but like we can just like quote the like function source code and evaluate it later with this SCI small Clojure interpreter. And with that, we can like capture the source code without any macros, but still, when we validate that, we can validate the like function itself. And it also gives guarantees for like always terminating, which is nice for having these. If the customers are writing their scripts, it would be nice that they are not in busy loop forever. Forms. So when we have schema as data, and we want to say, what does it look like? It's basically identity function, which just like checks out that some of the core schemas, like those integers, are turned into symbols. So this basically form returns the Schema AST, which is a valid schema itself. So you can validate with that. And this gives us the next nice thing called durable schemas. Schemas are data. We can write them into EDN, and we can read them from EDN, and they just work. And this doesn't require any macros, any eval. It just like works. And another library by Michael called EDAMEME ensures that when we are writing schemas, we can write regexps and these function literals. And this works with all JVM, ClojurScript, and graph. So you can write a schema, put it to the database, read it back, put it over the wire to the front end, use local validation, and it just works. This is awesome. Explaining data, thanks to clojure.spec, Rich and Alex, I think they perfected this way of like reporting errors. So this is directly from clojure.spec. If you have errors, you get this path and in indexes. So where in schema was the error and where in the value was the error. And we can build on top of that because humans are important too. And there's this small utility in top of the core called Malli error, and there's the humanize function. And it turns the like programmatic error explanation into human format. So here we can see we are trying to the composite map with some invalid data. There should be positive int, disallowed key, and the custom error we defined into the schema. This is nice. If you are using spec, you should probably use phrase, which is like doing the same for spec by Alexandra. It's great library too. Generating values, I will skip this because like it's basically test check, and like we are just using that. So you can generate values from any schema, from regexps, and you can have these schema hints which are literal data. That's nice. You can have this gen fmap, which says that generate some values, but when it's coming back, modify something. So you can just, and you can persist this too. But interesting thing, the same the other way around, inferring schemas. So if you have values and you want to get schema out, I've been using this at work, like scraping MongoDB for this random data which has been gathered for 7 years. So what does it look like? So here we have two examples of the restaurant, Liemi and Vanhatappi. It's another local great restaurant. And we would like to know what is the schema for that. So we use this Malli provider, small namespace, and say that provide me a schema from these two examples. And what it gives back is a restaurant schema, Schema AST. It's just data, it doesn't register anything, and it shows that this is the thing that you gave me to. And it has optional key, and this is important. So optionality in this context is important because some of the values had stars, some of them didn't have. So we need optional. And the groundwork for this from spec provider, taking from F# type providers, and like the current code is, I think it's 67 lines, so it's really simple, and it could be much better. So it guarantees that all the infer schemas, like they validate all the values, but they might not be optimal. So for example, if you have tuple, it will always guess that it's a vector. So we had this program with the data itself. We had the restaurant and we modified that. So could we do the same with schemas? Yes, we can. So internally there's two special protocols called map schema and length schema. And with those, we are able to make these generic like functions which work with all the schemas. So we can use all the same functions that are in core. We could use the same functions, but we wanted to put them in separate namespace because they have a bit specialarities. But here we have the map, and we just close it up recursively. We select some keys from the top level, we update the nested map in some path, and dissociate one key. And what we get back is a schema AST. It's a valid schema again. And as you can see, it's closed recursively. And this is actually old stuff also. So we built the same into schema tools in 2014, and we've been using this technique for quite some time, but it's like nice to get it in also. Another thing related to programming with schemas is like walking over schemas. So this is a nice exercise. I wrote this CLJ2251 into spec some time ago. So I would really love this to be in spec too. So spec should know how to walk over their children. So if you want to do something like spec to JSON schema transformation, just like say that walk it over, and when you get this node, so what you do with that. So own library, easy to implement. And there's this Malli visitor namespace, and then there's the JSON schema, Swagger2 schema, and the map syntax walkers. And you give it a schema and a function to like walk it over, and it does the transformation. And here's a good example of how simple the transformers are. So this is the actual source code for closing recursively a schema. So let's walk it through. So there's a schema, and we send it to this accept, which starts like walking over the schema. We pass in a visitor, and there's this simple thing which is this schema visitor, which is a function from schema to schema. So we get all the schemas in this callback, and we check that if the schema was an open schema, then we update the properties of the schema with Clojure assets closed true. So we close it up. Otherwise, we do nothing, so it does pass through. And that's all. And something like when designing the library, all these like add-ons like have been contributing to the core. So the core library is like a heart. And we have added lots of like protocols there to make these kind of things really simple. That's a benefit of doing your own library, so everything's simple. Some other nice features, so spell checking. So we wanted the schemas to be open by default, which is a good thing. It embraces growth. But also, if you have a typo, it doesn't have any guard for that. What can we do? Here's an example. Here's the restaurant schema we had, and some lovely Berlinian restaurant where I lost my voice yesterday. But traditional vegan food, and it clearly has some errors. It has two typos, stars and streets. And so it's not going to be valid. So how do we get the errors? So let's see the three styles. First, the open schema. We have the restaurant, we explain that against the data, and we humanize that. We see one error. This is not good. So street is missing key. So we had two typos, and it says that there's one error. So not very great. But we can close the schema. It's a pure function, restaurant, close it up, explain it, humanize it. Now we have three errors. This is better, but still not good. So the street, which is like missing required key, and two typos. Actually, two extra keys and one like missing required keys. So what do? Use the awesome magic by Bruce Hauman from the spell spec to have these like spell checking for the keys. Extra new pure function. We take a restaurant, we close it up, we explain it, we do the spell checking, and we humanize that. And now we have two errors. Address streets should be spelled street. Stars should be spelled stars. Now we have two errors. And good things that like no mutable anything, just like if we want this validation, we can just apply that. Last thing about these experiments was the value transformations. This was the original cause for spec tools. So we wanted this like runtime coercion things from schema into spec. And we did spec tools, and in schema tools we had the same thing. So it's like we knew how to do it probably, and like rewrite the whole like transformation engine like based on this rated lessons learned of making things fast, and it came actually pretty nice. So there's this mechanism of taking a schema and a value and a transformation context and optimizing these like functions to make the conversations. There's like encoding, decoding, and some ready-made transformers like reading from JSON in and out, reading from string formats like property files in and out, stripping extra keys automatically, applying defaults, and things like that. And schemas can override them. So if you write your schema, you can have these schema properties which say that if you are trying to decode me from JSON, do it like this. Some code for the restaurant. So we use the Malli transform namespace, again optional. We create this JSON transformer, which is a chain of transformations. First, we want to strip out all the extra keys. Then we apply the JSON transformations, and then we apply the defaults if they are set. Then we create this JSON to restaurant function. So we create a decoder for the restaurant in this JSON transformation context. And then we can send data. There's a lovely restaurant from Berlin, which has extra keys, and it's the best JSON can do. The type is a string, and we were expecting a keyword. The tags was supposed to be a set of keywords. JSON cannot do that. It's a vector of strings. But after the transformations, extra keys are taken away, and everything is transformed. That just works. And performance, this is the same, handwritten with Clojure. With my laptop 1.8 microseconds, with the engine 1.9. So there isn't basically much penalty. And the great thing is that the transformation compiler is quite smart. So there's an example about the order, which has some fields, and we are writing a transforming function. And actually it has nothing to do, because we have described a schema which is perfectly representable in JSON. So it knows I have nothing to do. It returns identity function, nothing to do. And that's like trying to do that by hand, so it would be a lot of work. So wrapping up, what's next? So it was an experiment, so would it be nice to have this new library, but it's almost out and it's integrated into Rated, so if you are using Rated, you can try that. The transformation coercion parse is like orders of magnitude faster than with spec tools. That's nice. There's an example of that, so if you're building APIs, you could check that out. And just yesterday we discussed about this using Malli for this building some kind of module or configuration system because of the spell checking and everything. It would be nice there. Some experiments I would like to do, schema providers. At the moment, for example, a JSON schema transformation is one way, so we can generate JSON schemas out of Malli, but we cannot do it the other way around. There's a good theory in F# type providers. That's a fun thing. I will probably try to do that. Or if someone wants to do this, I'm happy to see the results just. And we can, of course, create these JSON schema elements and say that we can run this JSON schema within Malli because all the schemas are responsible for the children, so they can have any kind of content. Generating UIs, this is like the holy grail. I just counted, I've done it in 4 different decades. My first startup was in '97 and we did huge Perl, Berkeley DB, form generation software. It was great. But there are lots of tools for that, but for some reason all the tools never survive to the next project. It's always like crappy and you have to reinvent the wheel. Now there's the Toronto guys, Dimitri, Carmen. They had this lovely talk about these healthcare systems they were building with Clojure, and they have been pushing this Domino CLJ out, and it will have this form generation, and about to integrate Malli into that. So looking forward to that. For developers, chatted with Ben about Expound. So what would explain should look like so that it would be easier to build these like pretty formatters, and this is the result. This is not out yet, but taken from Rated, so probably push into this Metosin Virhe library, which is just doing the formatting of the errors, and these two, Malli and Rated, will be using those. So these pretty errors. More tooling. There's this Aave, which is basically ghost wheel for Malli, done by Ryan. That's great. Goal was to have this like some kind of functions that could have schema annotations and maybe CLJ condo type annotations there, and write schemas for schemas themselves, so you could validate the properties. That would be nice. But actually yesterday I got it working, so I tried to do this, and this is the end result. Took me 15 minutes, thanks to CLJ condo. It's awesome. So just taking from prismatic schema the syntax, cursive knows that. There's a function which returns a tuple of intent, and it takes 2 ints. And with CLJ condo auto tooling, we can get this like before evaluating, saying that this requires an int. And so this is awesome. We'll finalize this definitely. So current status, where are we? It's pre-alpha. It started with pre-alpha because we are still experimenting, and there are stuff that when we are doing these new modules, we want to like put more stuff into the heart, so it might change. The public APIs are stable. People are using that. It's code complete, almost the core. But someone picked it up like months ago and it was in Reddit, so this new cool thing is coming, and now there's like lots of contributors and actually people using that, so it's good time to like finalize that. But Big thanks to everybody whose face was there or name was mentioned or just have been contributing to this, because like it was good to have it open, because so many like brilliant minds have been working with this. Try to get it out in a few months and learned a lot. But takeaways. So when we are working with open source, we should like understand and manage our expectations. That's important. And Clojure, I still believe that this data-driven system is the like killer app. Clojure is really good at them, and we should have more of these tools. Malli is almost out. It's a fresh new schema library. If you like it, go try it out. And if you're really good at these type or schema systems and are interested, we are taking all the contributors. So welcome and come contribute. And that's a URL, and we have this Malli channel on Slack. But that was my all, so thanks for listening and happy to take questions.
That was excellent, Tommy. Thank you very much. Yeah, I particularly liked like all the error messages seem to be, or the reporting is compatible with spec in many ways, it seems. Mm. And so that's really nice. Like people can kind of build exponents on for this, but also for spec, and like it will work kind of for both. It seems that there's some similarities between them. So that's very cool. Do we have questions? If you have a question, I'm going to come to you with the mic, and you will be able to ask a question. I'm seeing one.
Hey, you mentioned somewhere at the start that you can put regular expressions in your Malli, right? Yeah. Do you account at all there for differences between Java and JavaScript regular expressions?
No. So it might be that not all the regular expressions work. So I think you have excellent library coming up for that. So definitely want to check. And for example, the regex generation doesn't work at the moment in ClojureScript because of the small changes. So you can like have the regular expression, but if you try to generate on the ClojureScript side, it will give nothing to you.
Okay.
There's an issue in test check that, or test check actually.
Okay, thanks.
Thanks. Yeah, one more question.
So given Spec's dominance lately in sort of generatively testing your code base and how integrated that is with the core language, are you planning to sort of bridge the gap between the two so you could sort of hook Malli into the current ecosystem that uses Spec? I mean, a lot of libraries and core functions and macros are already dependent on spec. And I wonder how, I guess for me, using spec as my tool for these kind of validation things is that I don't have to write the same thing twice. Are you looking to bridge that sort of gap? So, I don't know, being able to generate specs from Malli or the other way, or do you have a solution for that?
That was a good question. So I don't have a solution for that, but there's an issue. I think one of the first issues that how they should be integrated together. And I think like ClojureSpec is really awesome for the things it does, and it's for like function, the core function, and like writing these like function level stuff. Where it doesn't shine is the like runtime, because it's not even meant for that. And I like Malli comes from the runtime perspective, and I don't know where they like meet, but definitely want to like because we use predicates also, so it should be doable to like generate specs out of Malli, maybe other one around too, but not going to like replace specs, just like giving options.
Cool. I think we might have time for like one more question. So you're the lucky one.
Thanks for the talk. Oh, I'm sorry. So thanks for the talk. And can you talk a little bit about performance? How is it comparing to schema or spec?
Yeah, so I might have a secret slide for that. Oh, I broke everything. So So the validation performance, I would say that it should be fast. So initial benchmarks say that Malli is maybe a few times faster, maybe 10 times faster, but that doesn't matter that much. But for runtime coercion, because spec tools has to walk over the specs basically, because there's no internal mechanism to do that. So it's like 2 to 4 orders of magnitude faster, Malli. So if you're using, for example, Composer API or rate it and using spec coercion and you swap to Malli, you will see your CPUs go down. Schema coercion, schema is really fast, and I only did like initial tests, but like they are on the same level basically. There's some things which like Malli is a bit faster, but schema does 2 things. It does like the coercion and the validation in the same sweep. So we have to do it twice. So the transformation is faster in Malli, but you have to validate it again. But we wanted to separate those because, for example, encoding. In encoding, you just first transform the thing and it might go into invalid mode. So if, for example, you want to turn something into string representation, your date goes into date string. If you validate it at the same time, it will fail because it's not a date anymore. So having them as 2 separate stages, it makes things much clearer. About the same should be.
Cool. All right, then let's thank Tommi one more time, and maybe also all the people that were in the slides, all the people that kind of indirectly and directly contributed to Malli and like many of the ideas. Thank you, Tommi.
Thank you.